Alright, so now we've discussed the basic properties of mirrors and lenses and how they work. Mirrors reflect, lenses transmit, despite the fact that all three of them do the same things. You should also at this point be incredibly familiar with if a wave comes in, is it going to bend in, is it going to bend out? If it comes in and hits a mirror, is it going to reflect in, or is it going to reflect out? You should know the basic ways that a wave is going to refract in the form of a lens or reflect in the form of a mirror. So to do ray diagrams, there are 3 rules you need to follow. That's it, 3 rules, with one special clause for rule number 2. But we'll get into that. Rule number 1, parallel to your principal axis and through the focal point. Keep in mind, this lens is a part of a complete circle of radius r. The focal point is always exactly half of that radius. So if you have a focal point equal to 20 centimeters, that's telling you that the radius of that circle that the lens is made out of is 40 centimeters. So the focal point's always half of the radius. Another thing that we need to discuss is that you must draw your principal axis right through it. Whenever you're drawing ray diagrams and how the wave will behave when it goes through, instead of having it refract at this point of the lens and this point of the lens, they use something called the thin lens assumption that goes along with the thin lens equation, where you have it come in straight until it hits the center point, and then you can have it refract. So it will refract towards the center since it's a converging lens. The waves are coming together. So rule number 1, parallel to the principal axis and through the focal point. So I'm going to undo that for a moment. And I'm going to draw my focal point here. And it'll be the same on both sides. So if it's 20 centimeters to the left, your focal point will be 20 centimeters to the right as well. So always draw both focal points. And it wouldn't matter if it's a simple convex lens or a double convex lens, it's going to behave the same way, because it's going to bend in when it gets to this first boundary, and then it's going to continue bending in. But again, as I just pointed out, you don't worry about that. You just worry about you get to the center point, or the center of the lens, and then you can worry about which way it's going to refract for lenses or reflect for mirrors. So rule number 1, parallel to your principal axis, and then through the focal point. And it is a good idea to use a straight edge to make sure that your rays come together in the correct location. So I've come in parallel to my principal axis, and I've gone through the focal point. Rule number 2 is through the focal point, and then parallel to the principal axis. So I'm going to draw the other wave coming from the person's head through that focal point. And then it's going to transmit and refract through the lens over here. Oh, I didn't connect my line all the way. I'm so sorry. So let me finish that wave. There we go. So number 1, parallel to the principal axis, and then through the focal point on the other side. Rule number 2 is through the focal point, and then parallel to your principal axis. Rule number 3 is through the center of curvature. And hopefully, if we've drawn this close enough to right, all 3 of them will converge at the exact same point. And we're just going to use a really big middle of R. That really should have gone through that perfect line. But it's close enough that it works. So now, the reason this works is because light comes in, bounces off of this person's head, and it bounces in every single direction. So you could have drawn an infinite number of waves, but we only care about these 3 waves because it makes it really easy. If we look at the top of the person's head, you need this wave, you need the wave through the center, and you need the wave through the focal point. Also, since the waves are coming together, we're using this back focal point. Or rather, I like to think of it as the correct focal point. A lens, you would expect the waves to end up on the other side. So this is where the image should appear. This is where the image should occur. And with a converging lens, they do all come together at that point. So that's where the top of the person's head will appear. Now we could have drawn these waves coming out from all of them, but suffice it to say, you're basically going to have an inverted person. So this person is inverted. He's upside down, his head is down here. If we drew an arrow instead, then you would have had an upside down arrow if you placed a screen at that point. So this is the correct focal point because you would expect the image to appear over here. Now, with a concave lens, and with ray diagrams, I always like to start with a crude diagram before I draw the actual ray diagram. With a concave lens, you know that the rays are going to splay out, which means you're not going to get a real image over on the right side. You know that the waves, the light rays, are going to go to the right. The light rays aren't going to reflect back because it's a lens. So you want the image on the right side. So with a lens, and this is only true for lenses, doesn't matter if it's convex, concave, the light waves should end up over here. And if you get an image over here, it's going to be real. If the image appears on the left-hand side, then it's a virtual image. And that's because the image won't actually show up on the left-hand side. Keep in mind, it's a lens. The waves are going through. Your real image should be on the right-hand side. And with this first diagram, since the waves were coming together, we know that it's correct. We know that it's going to be a real image. So the clause to rule number 2 that I added down here is you use the behind focal point for lenses and mirrors that are small in the rays. That's going to be relevant to this guy and this guy. But let's go through the other easy one first. With a convex mirror, again we need to draw our principal axis. That's a great straight principal axis. And I'm going to draw my object that's hopefully going to be reflected. Now, if it's being reflected, where would you expect the real image to appear? If it appears on this side, it's a real image. However, if your rays come together on the other side, it's going to give you a virtual image. So if the waves come together where they're supposed to, it's real. If they come together where they're not supposed to, it's virtual. Up here, lens comes through. That's where the image is supposed to appear. And since the waves did come together over here, it's a real image. So if our waves come together on the left-hand side for a mirror, since it's reflecting back, that would give you a real image. But if your waves come together on this side, it's a virtual image. Now, keep in mind, I said start with a crude diagram. Well, I know that these waves are going to reflect in, right? So the reflection's going to be on this side. And they're going to be coming together. So your rays are coming together. That's very important. Are your actual rays spraying apart or coming together? With a convex lens, they're coming together. With a concave mirror, they're also coming together. Think about if you shine a flashlight here, 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 here. They're all going to keep shining back towards some sort of center point. So your rays are coming together. If you can think about it logically, you don't have to memorize any rules for that. So because the waves are going to come together on this side, it's the left side of the mirror, which is going to give us a real image. Or at least it should. So let's actually go through and draw our ray diagram. And let's use green. Rule number 1, parallel to principal axis and through the focal point. Oh, I didn't add a focal point. Focal point here. And a focal point about the same distance on the other side. So rule number 1 never changes. Parallel to the principal axis. And I'm going to come to my center of the mirror and then through the focal point. There we go. Rule number 2 is through the focal point. So this is the focal point we want to use because it follows the rules. The rays are on the correct side of the mirror. Or rather, because the real rays are coming together, you use your actual focal point. So rule number 2 is not changed. So through the focal point, and then reflecting parallel. And rule number 3, through the center of reflection. So there's about the center of my mirror. There we go. And it's going to reflect back the exact same angle. There we go. And all of our rays converge right there. So that's where the top of the person's head would be. All right. So to try to clarify what I'm trying to convey, if the rays come together after either going through the lens or bouncing off of the mirror, if the actual rays come together, rule number 2 is not modified. You follow rule number 2 exactly as it appears. You go through your focal point and then reflect, or through your focal point and then refract. Basically through focal point and then parallel. And rule number 2 is pretty much the same for these other 2 situations, but slightly modified. So now let's look at a concave lens. First, I'm going to draw my principal axis. And I'm also going to draw a crude diagram. Waves come in, and I know that they're going to scatter. If your waves are scattering, you use the behind focal point. So my actual waves are scattering, so I'm going to have to use the behind focal point for rule number 2. Rule number 1 never changes. Waves are scattering, or the actual waves are scattering, use the behind focal point. So I'm going to say that this lens has a focal point of F. Make sure you draw it on both sides. And let's draw our person. Rule number 1, parallel to principal axis and through the focal point. But wait a minute. This wave is going to scatter. So I know from my crude diagram that it has to go up. To know the angle that it goes up, you need to use your focal point. And again, rule number 1 always uses this leftward focal point. So I came in parallel, and then I knew that I've scattered up. And because I scattered up, I used my focal point to know what angle it would scatter up at. Rule number 2, through the focal point and parallel to the principal axis. But the question is, which focal point am I going to use? Rule number 2, use the behind focal point if and only if the actual rays are scattering, which they are. So we're going to use the behind focal point for rule number 2. So we're going to draw a ray diagram. Oh, that's a solid line. To that behind focal point. And then along the parallel axis. So the image is, or the actual ray is going to continue straight. And rule number 3, through the center of curvature. So from the top of the person's head, through the center of my lens, and that's the way it's going to go. But wait a minute, those waves don't come together at any point. To fix that, I think I had the rule, this is not going to give you a real image because the images are not, or the waves are not converging anywhere on the side of the lens that they should be converging on. The waves come through on the right side, but they don't converge on the right side, which means you're not going to get a real image for this lens, for any concave lens, excuse me. So that's where this clause comes in. Draw the other rays for virtual images. Well, we already know that we're crossing at this point. And your third line, if you continue it backwards, should always come through that converging point. So that's where the top of the person's head would be. You'd be like, oh my gosh, there's the little person. An image will not actually show up there if you put a screen there. But that's where the image should show up. That's why it's called a virtual image. You notice that that virtual image is upright. The person is still standing up correctly. All right, rule number 4, concave mirror. As always, I'm going to start with a crude diagram. The rays are going to bounce up, the rays are going to bounce out, which means rays are scattering. You can't even see that anymore. But the rays are scattering. What does that mean? That's right. For rule number 2, you need to use the focal point that's not the one you would expect, or the focal point on the right side of the lens or mirror. So you need to use the right-hand focal point when the rays are scattered, when the actual rays are scattered. I know I've said that about 10 times, and I'm really, really hoping it makes sense what I'm trying to say. If it doesn't, text me. All right, we've drawn our principal axis. Now let's get a person going on. Let's get a focal point. Let's get a focal point on this side. Those are about the same distance. All right, rule number 1 never changes. Parallel focal. Parallel. And from my crude diagram, I know that that ray is going to bounce somewhere up in this direction. the angle you need to use is from your focal point. And again, the actual rays aren't going to appear behind a mirror, so I'm using a dotted line to represent them. And that ray is going to reflect that way. Sometimes it's easier just to jump to rule number 3. Go right through your center of curvature. It's going to hit there. And I'm going to draw that dotted line. I'm just going to continue it out. But we know it's going to reflect back at the same angle it came in at. So I'm going to try to draw somewhat close of the same correct angle. And rule number 3, or rule number 2, is through the focal point parallel to the principal axis. But which focal point do we use? Why did we use the behind focal point? Yes, because the actual rays are scattering. So I'm going to use that behind focal point and then still follow rule number 2. And then parallel to the principal axis. Okay. Easy enough. Should we do a couple more practice problems together? And let's actually apply some numbers when we do more practice problems. So I'm going to take a second, look up a couple practice problems so that way we're all on the same page, and we'll work through them together. Thanks.